This is the Edexcel higher tier paper 1 non-calculator paper from November 2022. Let's get started. Question 1 says write 500 as a product of its prime factors. So we need to break 500 down into its factors until we've just got prime numbers left. So we'll start with 500 and we can break it down. What two numbers multiply to make 500? I'll start with 2 times 250. So 2 is a prime number. It can't go down any further than that. We can't break 2 down anymore. It's already prime. So we'll leave it. 250, we can do 2 again, times 125. 125 we can break down again. It's in the 5 times table. 5 times 25. And 25 is 5 squared. So 5 times 5. So 500 can be written as 2 times 2 times 5 times 5 times 5. If we did 5 times 5, we'd get 25, and then times that by 5 will be 125, and then times that by 2, 250, and then times that by 2 would be 500. So 500 is 2 times 2 times 5 times 5 times 5, or even 2 squared times 5 cubed. Question 2. Work out 1 3/5 plus 2 1/4. Give your answer as a mixed number. So given our answer in the same form that the question is written in. I'm going to change them both into top-heavy fractions first, improper fractions. So 1 3/5, a whole one is 5/5. So 5/5 and 3/5 make 8/5. 2 whole ones in quarters will be 8 quarters, plus another quarter is 9 quarters. So I've got 8/5 and I've got 9 quarters. I'm going to add them together. To add fractions, we need to make the denominators the same. So these bottom numbers have to be the same. I'm going to times the top and the bottom of my left fraction by 4, and the top and the bottom of my right fraction by 5, which will make both the denominators 20. 4 8s are 32, and that's 20ths. And 9 5s are 45, and 4 5s 20ths. So we've got 32 20ths plus 45 20ths. Now the denominators are the same. I can just add them now. So 32 and 45 make 77. So that's the answer, but it's not written as a mixed number. So how many 20s go into 77? That will be 3 to make 60. I've got 3 whole ones, and then I've got 17 more. So 3 whole ones and 17 20ths. Part B, show that 2 2/3 divided by 6 equals 4/9. So 2 2/3, again, I'm going to change that to a top heavy. 2 3s are 6, plus 2 is 8. So 2 2/3 is 8/3. When we have a division, we can change it into a multiplication if we flip over the thing we're dividing by. So we're dividing by 6. The reciprocal of 6 is 1/6. So I can change this to 8/3 times 1/6. Then just times the top, times the bottom. That's how we multiply fractions, times the top, times the bottom. We could simplify first or simplify after. Doesn't matter which way round we do that. 8 times 1 on the top is 8. 3 6s on the bottom is 18. So we've got 8/18. And to simplify, half the top, half the bottom, and we've got 4/9. That's what we wanted. Question 3. Simplify 2 to the power of -5 times 2 to the power of 8, all squared give your answer as a power of 2. So when we multiply indices, we add the powers. So for the bit inside the bracket, -5 plus 8 is 3. So that's going to be 2 cubed squared. And when we have a bracket, we just times these powers. So 3 times 2 is 6. So the answer is 2 to the power of 6. You can also think of this 2 cubed squared as 2 cubed times itself. And when you multiply indices, you add the powers. So you get 2 to the power of 6. Question 4. Work out 0.004 times 0.32. So we could change this into standard form and then answer a standard form question. Or we could use multiplying decimals, which I will do. So I'm just going to work out 4 times 32. I'm going to take the decimals out of the question, but I'm just going to make a note of what I've done here. So I've multiplied 0.004 by 10 3 times, 3 numbers after the decimal point, and I multiplied 0.32 by 10 2 times. So in total, I've multiplied by 10 5 times. There are 5 numbers after the decimal point in the question, so I'm going to want 5 numbers after the decimal point in the answer. So let's just do 4 times 32. 32 doubled is 64. 64 doubled is 128. So that's 128. And I want 5 numbers after the decimal point. So it's going to be 0.00128. 1, 2, 3, 4, 5 numbers after the decimal point. A car factory is going to make 4 different car models, A, B, C, and D. 80 people are asked which of the 4 models they would be most likely to buy. The table shows information about the results. And they're going to make 40,000 cars. How many Model B cars should they make? So 15 people out of 80 like Model B. So we want, it's like an equivalent fractions question. 15 out of 80 is going to be the same as 40,000 on the bottom, so something out of 40,000. If 15 out of 80, like Model B, how many would that be out of 40,000? So how can I make these the same? If I half the top and the bottom, I'll get 40 on the bottom, and then times by 1,000. So 7.5 times 1,000 will be 7,500. Question 6. Rizwan writes down 3 numbers, A, B, and C. The ratio of A to B is 1 to 3. B to C is 6 to 5. Find A to B to C. So to make them all one ratio, we need the thing in common, the B's, to be the same. So it's 6 in the B to C ratio. It's 3 in the A to B ratio. So we can just double the A to B ratio. So A to B is 1 to 3. If I doubled it, it would be 2 to 6. And B to C is 6 to 5. So now B is the same. I can just write them together, A to B to C, 2 to 6 to 5. And we can see that A to B is still in the ratio 1 to 3, and B to C is still in the ratio 6 to 5. Express A as a fraction of the total of the 3 numbers. So the total, 2 plus 6 plus 5, is 13. And A is 2 parts, so 2/13. Emma writes down 3 numbers, M, N, and P. So we're given them in equation form, and we want the ratio M to P. So we need to change this equation form into ratio form. N is equal to 2m. So what's the ratio of n to m? So if m is 1, so 2 ones are 2. M would be 2. If m was 2, m would be 2 times 2, 4. If m was 3, m would be 6. So the ratio of m to n is 1 to 2. It kind of flips over. So we've got 1n equals 2m. So the ratio is 2 to 1, n to m. So for every one part m is, n is double it. So whatever m is, n is double. P equals 5n. So if n is 1 this time, p would be 5. This time p is 5 times as much as n. So the ratio is 1 to 5. If n was 1, p would be 5. If n was 2, p would be 10. If n was 3, p would be 15. The ratio is 1 to 5. Let's make the n's the same. So let's double our n to p ratio. So that'll be 2 to 10. And then we can write m to n to p as 1 to 2 to 10. And we wanted the ratio m to p. So m to p is 1 to 10. Just cross out the n. 1 to 10. Question 7. A storage tank exerts a force of 10,000 newtons on the ground. So we've got pressure equals force over area. That's the force is 10,000 newtons. The base of the tank in contact with the ground, so the area, is a 4x2 rectangle. So the area of that rectangle is 8 meters squared. So the area is 8. Work out the pressure on the ground due to the tank. So pressure is force over area. We've got 10,000 divided by 8. So let's simplify this. Half the top, half the bottom. 5,000 over 4. Half them again. 2,500 over 2. And half of 2,500 be 1,250. So the pressure is 1,250 newtons per meter squared. Question 8. Two numbers m and n are such that m is a multiple of 5, so anything in the 5 times table, so 5, 10, 15, 20, 25, 30, and so on. N is even, and the highest common factor is 7. Write down the possible value for m and a possible value for n. So the highest common factor is 7. So they've both got to be multiples of 7. So multiples of 7. Let's just jot down 7, 14, 21, 28, 35, and so on. N is any even number. And m is a multiple of 5. Our lowest multiple of 5 that has a factor of 7 is 35. It's in the 5 times table and the 7 times table. And n is an even number. It's also got to be a multiple of 7. So we could have 14 or 28. So both of those, if I had 14 and 35, if I had 14 and 35, m is a multiple of 5, which it is. N is an even number, which it is. And the highest common factor is 7. Yep, the highest common factor is 7. So that would work. 28 would also work if it was 28 and 35. So m is a multiple of 5, n is even, and their highest common factor is also 7. So yeah, so either of those, let's go with 35 and 14. Question 9, complete the table of values for y equals 6x minus x cubed. So we've got 6 times x minus x cubed. Let's start with 1, that should be easiest. So when x is 1, what is y? 6 ones minus 1 cubed. 6 ones are 6. Take away 1 cubed. 6 take away 1 is 5. 0. So 6 zeros take away 0 cubed is 0. Negative 1. 6 negative 1s take away negative 1 cubed. 6 negative 1s are negative 6. And then we're taking away negative 1 cubed. Negative 1 cubed is negative 1. So it's negative 6 take away negative 1. So negative 6 plus 1, negative 5. And negative 2 is probably going to be negative 4. Let's just check it out. So 6 times negative 2, take away negative 2 cubed. 6 times negative 2 is negative 12. Then we're taking away negative 2 cubed, which is going to be negative 8. So negative 12 plus 8, negative 4. So let's just draw this. I've got negative 3, 9. Negative 2, negative 4. Negative 1, negative 5. 0, 0. 1, 5. 2, 4. And 3, negative 9. So let's just draw the graph. Something like this. Question 10. Lena spins a bias 5-sided spinner 40 times. Here are her results. Lena is now going to spin the spinner another 2 times. Work out an estimate for the probability she gets a 5 both times. So she got a 5 10 times out of 40. So 10 out of 40 is the same as 1/4. So our estimate is that the probability of getting a 5 is 1/4. That's a quarter the first time and a quarter the second time. So when we've got 2 trials, we times the probabilities. A quarter times a quarter is a 16th. Derek is going to spin the spinner a large number of times. Work out an estimate for the percentage of times Derek can expect to get a score of 1. So it was 6 out of 40. What's that as a percentage? So that's half them, 3 out of 20. And then times by 5 to make the fraction out of 100. That's a percentage. 15 out of 100, 15%. Question 11. Describe fully the single transformation that maps shape P, so the big one, onto shape Q, the small one. So even though it's got smaller, it's called an enlargement. The scale factor is, so P had, well, the bottom was 3, it's now 1. The scale factor is 1/3. And what's the center of enlargement? Let's join up the points. The center of enlargement, we join up the points, they all go through 0, 2. Center, 0, 2. So 3 bits of information we need here. The transformation it is, which is an enlargement, the scale factor, and the center of enlargement. Question 12, solve the simultaneous equations. We're going to solve them by elimination, which means we need to make the x's the same, or we need to make the y's the same. I'm going to make the x's the same. I'm going to times the top one, the whole of it, by 4, and the whole of the bottom equation by 5. So that will give me 20x plus 8y equals 44, and 20x plus 15y equals 30. So I've made the x's the same. I can now get rid of them. I can eliminate them by just looking at the difference now. So the difference, that means a take away. I'm going to say I'm going to take away, I can either do the top equation from the bottom equation, or the bottom equation from the top equation. It doesn't matter which way round I do it. I'll just do the top from the bottom. So 20x take away 20x is nothing, it goes. 8y take away 15y will be negative 7y. And 44 take away 30 is 14. So negative 7y is 14. Divide both sides by negative 7. Y must be negative 2. And now we know y, we can substitute it back in. So we know 5x's in the top one, the very top one here, plus 2y's, and I know y is negative 2. So 2 negative 2's must equal 11. 2 negative 2's make negative 4. So 5x take away 4 must be 11. Add 4 onto both sides. Divide both sides by 5. X is 3. And we can check our answer on the second one. So 4x, 4 3's are 12, plus 3y's, 3 negative 2's, which would be negative 6. So 12 take away 6 is 6. And that is correct. Question 13, P is inversely proportional to T. Complete the table of values. So if P is inversely proportional to T, that's the relationship where as one goes up, the other one goes down. Or we can write it as P equals K divided by T. So K is just a number, and we can work out what that number is. So the relationship is P equals something divided by T. And we can work out what that something is by substituting in these numbers, 1 and 100. So when P is 1, T is 100. So 1 equals K divided by 100. K must be 100. So the relationship between P and T is P is 100 divided by T. Or you could think of this as P and T have to multiply to make 100. They are two numbers that multiply to make 100. 1 and 100 multiply to make 100. 25 and 4, 5 and 20, and 2 and 50. So you can check they all fit this equation. So P is 100 divided by T. 1 is 100 divided by 100. 4 is 100 divided by 25. 5 is 100 divided by 20. And 50 is 100 divided by 2. Question 14. The table shows information about the weights in grams of some potatoes. Draw a histogram. When we have a histogram, we have bars that aren't equal width. Some are thin, some are really wide. But the area represents the frequency. So the number of potatoes is going to be the area of each bar. And up the side here, we've got frequency density. So the frequency density is going to be the frequency, the number of potatoes, divided by how wide the bar is. So 50 to 70 is 20 wide. 70 to 80 is 10. 80 to 90 is 10. And 90 to 110, that's 20 wide. So the frequency density, the height of the bar. So if the area is 20, the width is 20, the height must be 1. So frequency density, frequency divided by width. 20 divided by 20 is 1. 50 divided by 10 is 5. 60 divided by 10 is 6. 30 divided by 20 is 1.5. So they're the heights of the bars. We're going to have 1, 2, 3, 4, 5, 6 up the side. So our first bar goes from 50 to 70, and it's going to have a height of 1. So from 50 to 70 with a height of 1. Our next bar, 70 to 80 with a height of 5. Then 80 to 90 with a height of 6. And 90 to 110 with a height of 1.5. So then we'll be able to see the area of each of these bars makes the frequency. The area of the first bar is 20, the second one is 50, then 60, then 30. Question 15. The diagram shows a sector of a circle, radius 18. The length of the arc, so the arc is this bit here. It's part of the circumference of the circle, and that's 4 pi centimeters. Work out the value of x, work out the angle. So we know the arc length can be written as what fraction of the circle have we got? So the angle out of 360, that's the fraction. So I shouldn't have put theta there, I should have put x, because x is the angle. So that's the fraction of the circle we've got. So this fraction of the circumference, which is 2 pi r, or 2 pi times, no, 2 pi r, or pi times the diameter. So this fraction of the circumference is 4 pi. And then we can just work out what the missing number is. What is x? So let's divide both sides by pi to start with. So that gives us 2 18s, which is 36. X divided by 360 equals 4. And then simplify this fraction, divide top and bottom by 36. So x over 10 equals 4. X must be 40. So x is 40 degrees. Question 16. Prove that 2m plus 1 squared minus 2n minus 1 squared is equal to 4 times m plus n times m minus n plus 1. So let's just get started. We're expanding and simplifying this. So we're going to have double brackets, 2m plus 1 times 2m plus 1. Take away 2n minus 1 times 2n minus 1. Now we're going to have to be careful with this takeaway, because we're going to want to take away all of this second expansion, not just the first term of it. So expand and simplify. 2m times 2m, 4m squared. 2m times 1 is 2m. 2m times 1 is 2m. And 1 is 1. I'm going to leave a bracket in here. 2n times 2n is 4n squared. 2n times negative 1 is negative 2n. Negative 1 times 2n is negative 2n. And negative 1 times negative 1 is positive 1. So we'll have 4m squared plus 4m, collecting the like terms, plus 1. Take away all of 4n squared minus 4n plus 1. Now let's take away all of the terms in the second bracket. So 4m squared plus 4m plus 1 minus 4n squared minus minus, so plus 4n minus 1. And that leaves us with 4m squared plus 4m plus 1 minus 1 cancel out. So we've got minus 4n squared plus 4n. So we can easily factorize the 4 out of here. So let's take the 4 outside. And so we just do that first. So take the 4 outside. I'm going to write m squared, and then I'm going to write minus n squared, then plus m plus n. So I still need to change this bit inside the bracket into m plus n times m minus n plus 1. I think the best way to do it is to change, or the way to do it, we're going to use the difference of two squares. So m squared minus n squared, m squared minus n squared is the same as m plus n times m minus n, the difference of two squares. So I've got 4 times, I've got m plus n times m minus n, and then I've got plus m plus n. And then if I put a bracket around the m plus n, we can see that m plus n can be factorized out. It can come on the outside. And that's what's happened here. So the m plus n comes onto the outside. So it's going to be 4 times m plus n. Then what's left inside? So this is just the same. So the m plus n here is just the same as having 3x plus 3. I'm factorizing out the 3, changing it into 3 on the outside, and then x plus 1 on the inside. We're just doing exactly the same as this, but we've got, instead of 3, we've got m plus n that we're taking out. So m plus n comes out. That leaves m minus n as the first term, and the second term is just 1. And that is what we wanted. Sophia says that the result in part A shows that the difference of the squares of any two odd numbers must be a multiple of 4. Is she correct? So yep, this is two odd numbers, and it's the difference of the squares of them, and it's a multiple of 4. So yes, because 2m plus 1 squared minus 2n minus 1 squared is the difference of the squares of two odd numbers, and it is a multiple of 4 because we have factorized 4 out of it. Question 17. Work out the value of 8 over 27 to the power of 4 thirds. So the thirds, if we have a power of a third, that's the same as a cube root. So we're going to cube root these, and then it's the power of 4. So we want to cube root first. We don't want to do the power of 4 first. We don't want to do 27 times 27 times 27 times 27. It'll be way too complicated. So cube root first. So get rid of the cube root. So the cube root of 8, what number multiplies by itself and itself again to get 8? That's 2. The cube root of 27 is 3. So we've got 2 thirds to the power of 4. So we've got 2 to the power of 4 on top, 2 times 2 times 2 times 2. And on the bottom, 3 times 3 times 3 times 3, which is the same as 9 times 9, which is 81. Question 18. A and B are points on the circle, centre O. DBC is a tangent, we can see on the diagram. AOB is x. Show that angle ABC is half of x. Give a reason for each stage of your working. So when we have a tangent and a radius, they meet at a 90-degree angle. So we can say DBO, and the other side, OBC, are both 90 degrees because a tangent meets a radius at 90-degree angle. We've got an isosceles triangle here because we've got two radiuses. So this angle here and this angle here, so that's OBA and OAB, are going to be 180 degrees for the whole triangle. Take away x and then divided by 2. So 180 minus x over 2. And that's because the angles at the base of an isosceles triangle are equal. So 180 minus x over 2. We want ABC, so it's just going to be 90 take away 180 minus x over 2. So it's going to be 90 take away 180 minus x over 2. And let's simplify the 180 minus x over 2. That's half them both. So it's going to be 90 take away 90, half of 180, minus half of x. So 90 take away 90 is nothing. And then take away negative half x is half x. Question 19. Solve 1 over x minus 1 over x plus 1 equals 4. Give your answer in the form a plus or minus b root 2, where a and b are fractions. So we want to add these fractions together. To add fractions, we want to make the denominators the same. So I'm going to times top and bottom of 1 over x by x plus 1. And I'm going to times top and bottom of 1 over x plus 1 by x. Now I can make them into one fraction. So I've got x plus 1 minus x on top, which is just going to be 1, over x times x plus 1. So I've got 1 over x times x plus 1 equals 4. Times both sides by x over x times x plus 1. So we've got 4 times x plus 1. Expand the bracket, so 4x squared plus 4x. So we've got a quadratic. To solve a quadratic, we make it equal to 0. So I'm going to write 4x squared plus 4x minus 1 equals 0. So we've got our quadratic ready to solve. We need to give our answer in the form a plus or minus b root 2, where a, b, and c are fractions. No, where a and b are fractions. So we can use the quadratic formula. That's going to be the easiest way, I think. So a is 4, b is 4, and c is negative 1. And the quadratic formula tells us that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a's. So we've got minus 4 plus or minus the square root of 4 squared minus 4 times 4 times negative 1 all over 2 4's. So that's minus 4 plus or minus the square root of, so we've got 4 squared, which is 16, minus 16 times negative 1. So 16 minus minus 16 is 32 over 8. We want our answer in the form a plus or minus b root 2. So we are going to have to change root 32. So square root 32. What times by root 2 to make root 32? It's the same as root 16 times root 2. And root 16 is 4. So square root 32 is the same as 4 root 2's. So we've got minus 4 plus or minus 4 root 2 over 8. We want it in the form a plus or minus b root 2. So we'll have 4 over 8. 4 over 8, they're both a half. So it's minus a half plus or minus half root 2. Question 20. Alfie has 11 cards. He has 3 blue cards, 7 green cards, and a white card. He takes 2 cards at random. What's the probability he takes cards of different colours? So we could work out all the different combinations: blue, green, blue, white, green, blue, green, white, white, blue, and white, green. Or we could work out the probability of the same colours and then do 1 minus the probability that the colours are the same. And that should be a bit quicker. So the probability of blue, then blue. So the chance of getting a blue card the first time, there are 3 blue out of 11 in total. The second time, he's already got a blue, so there are 2 left out of 10 in total. So the chance of blue, blue is 6 out of 110. The probability of green, green. So the first one, 7/11. The second one, if he's taken one, there's 6 left out of 10 cards. That'd be 42 out of 110. And I'm not going to use a white pen here. Oh, we can't get too white anyway. So the probability of white is 0. Impossible. So the probability, so we want the probability of the same color. It can be blue, blue, or green, green. So that's 48 out of 110. So the probability of different colors, 1 minus 48 out of 110. So 110 110ths, take away 48 110ths is going to be 62 110ths. We don't have to simplify it. That answer is good. Question 21. The diagram shows a sketch of the cos graph. P is the minimum point. What are the coordinates of P? So the cos graph goes between 1 and -1. And it goes 90 degrees, 180, 270, 360, and then repeats all over again. So it does a complete wave in 360 degrees. So the coordinates of P are 180, -1. Question 22. Work out the value of sine ABC, 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 Give your answer in the form m over n, where m and n are integers. So we're going to be using the sine rule, and the sine rule involves the opposites. So we can say that sine a over a equals sine b over b. So in this case, sine ABC over 6.5 is equal to sine 30 over 10.7. Sine 30. So we've got a non-calculator paper. We need to know what sine 30 is. There's different ways of remembering it. We can either draw a triangle or this. So I'll write sine cos over 2, 0, 30, 45, 60, 90. And it's 0, 1, 2, 3, 4, 4, 3, 2, 1, 0. So sine 30 is square root 1 over 2, which is, well, square root 1 is 1. So sine 30 is 1/2. I won't do the triangle right now. It might just take up too much time. So sine 30 is 1/2. So sine ABC is 1/2. I'll write 0.5 over 10.7 times by 6.5. And we have to give our answer in the form m over n, where m and n are integers. So how can I simplify this? Doesn't look too nice. So if I times by 10, times top and bottom by 10, and get 5 over 107 times 6.5, and then times double the top and bottom again. So I have 5 times 2 6.5s are 13 over double 107, 214. 5 13s are 65. So I've got 65 over 214. I don't think I can simplify it, but it doesn't matter because they're integers, they're whole numbers. So as long as we've got whole numbers there, we've answered the question. Question 23. Here are the first 5 terms of a geometric sequence. So a geometric sequence, it's got a common ratio. You times by the same number every time. So if we had 2, 6, 18, 54, if we times by 3 every time, that'd be a geometric sequence. So what is this one timesing by every time? So root 5 goes to 10, and then 10 goes to 20 root 5. So what do you times 10 by to get 20 root 5? 10 times something is 20 root 5. It must be 2 root 5. So to go from one term to the next term, we times by 2 root 5. So the next term is going to be 400 root 5 times 2 root 5. 400 times 2 is 800. Root 5 times root 5 is 5. So 800 times 5 is going to be 4,000. The fourth term of a different geometric sequence is 5 root 2 over 4. The sixth term is 5 root 2 over 8. Given that the terms of the sequence are all positive, work out the first term. So what's the common difference this time? So 5 root 2 over 4 times something and times by that same something again. So times something squared is 5 root 2 over 8. So this r squared is going to be a half, because 5 root 2 over 4 times a half is 5 root 2 over 8. So r squared is a half. So the common ratio must be the square root of a half, which you can write as 1 over root 2 or a half. But we want to know the first term. So we need to go back 3 times. So we need to divide by, so it's the fourth term, 5 root 2 over 4. So if we go forwards, we times by the common ratio. To go back, we divide by the common ratio. So divide by it once to get the third term, twice to get the second term, 3 times to get the first term. So we want to divide by 1 over square root 2 3 times to get our first term. So let's cube it first. So that's 5 root 2 over 4. 1 cubed is 1. Root 2 cubed, so root 2 times root 2 times root 2. So root 2 times root 2 is 2, and then 2 times root 2 is 2 root 2. And to divide by a fraction, we can change it to a times and flip it over, the reciprocal. And then we'll just multiply this, so 5 times 2 is 10. Root 2 times root 2 is 2. So 10 times 2 over 4, 20 over 4 is 5. So the first term was 5. Question 24. Here is a solid sphere and a solid cone. The volumes are equal. Find the ratio of R to H. So the volumes are equal, so 4/3 pi r cubed equals 1/3 pi r squared h. So we're just going to simplify this, so times them both by 3, divide both sides by pi, and divide both sides by r squared. What's left? So you've got 4r equals h. We want the ratio of r to h. So when r is 1, h is 4. When r is 2, h is 8. The ratio is 1 to 4. Here is a different sphere and cone. The surface area of the sphere is equal to the total surface area of the cone. So it's solid. Find the ratio r to h. So we've got the surface area of the sphere, 4 pi r squared, equals the total surface area of the cone. So it's pi r L plus, so that's the curved surface area, plus the base, which is a circle, so pi r squared. We don't want, let's divide through by pi and divide through by r. That would just make it a bit simpler. So we've got 4r equals L plus r. So 3r equals L. But we don't want L, we want h. So what we've got here is a right angle triangle. We can change L into 3r's, that might make it easier. And what is h? So how can we get h in terms of r? We can use Pythagoras. R squared plus h squared equals 3r squared. R squared plus h squared equals 9r squareds. H squared is 8r squareds. H square root both sides. H is root 8 times R. Root 8 R. What do I need? The ratio of H to R. So H is equal to root 8 times R. So when R is 1, H is root 8. So that's the answer, 1 to root 8.